Hello guys, today we're going to look at section 4.6, which is cryptography. So when we hear the word cryptography, sometimes cryptology is also used as the study of the cryptography. And so when we talk about cryptography, this is the subject of transforming information so that it cannot easily be recovered without special knowledge. And so we're going to look at what we call encryption and decryption today. So encryption is the science of changing data so that it is unrecognizable and useless to an unauthorized user. And then decryption is changing it back to its original form. So for instance, cryptography is used when you're buying something over the internet. So there are codes that encrypt your credit card number. So when it's in the air, no one knows. You know the key because you know your credit card number. And then when it gets to where it's going, so you're buying something from Amazon, they have a key, which is the decryption. And therefore, they can get your credit card number to make your purchase. So this is just a visual representation of cryptography. So say you want to send the message, hello world. That message is what we call plain text. And then it goes to an encryption where there is a key. So you know the key of what it is. So when it's out and when it is encrypted, it becomes what we call cipher text. And then it is sent to where it needs to go, where they also have the key to decrypt it, and then it is brought back to plain text. So one of the simplest methods of cryptography is what we call the Caesar cipher. Okay, and so the Caesar cipher was created by Julius Caesar, and it is what we call a shift cipher, and it shifts each letter of the alphabet 3 letters forward. Okay, so for instance, if you, and it says in this case, sending the last 3 to the first 3 of the alphabet. So for instance, if you have B, you will shift 3 forward, B, E, F, B, what does that have to be? C, D, E, sorry. And so it would go to E, okay? And likewise, X would go Y, Z, and then the third would be A. Okay, so this is the process of encryption. And so let's see how the Caesar cipher works. Okay. So we replace integers in what we call Z6. So Z6 are the integers from 0 to 25. So we have to remember that first alphabet letter goes, the A goes to 0 and Z goes to 25. So, A would go to 0 and Z would go to 25. Okay. And so each position is represented in that form. Okay. So our goal here now is we want to encrypt a function. So we want to encrypt a function. And so we're going to use this formula here. P of F is equal to P plus 3 mod 26. So what does that mean? The P represents the original letter that you're representing. The plus 3 is our shift we're adding since we're using the Caesar cipher. And mod 26 is our Z26. So we want to know what would that remainder be in this case. Okay. So for instance, if we want to encrypt the message, meet you in the park, using the Caesar cipher. So MEET, I won't write the rest, but if you look above, you'll see that the M represents the 12, the E represents the 4, and the T represents the 19. So if we want to represent the M, yes, we'll do F of 12, and our formula says we'll do 12 plus 3 mod 26. So we get 15 mod 26. This actually gives me 15. And so therefore, 15, we go back to our cipher and notice that 15 represents P. So the first letter of this encryption would be P. we'll do, say, one more. Let's just do the E. So E represents 4. So we'll have what, 7 mod 26, which just gives me 7. And we see above that 7 represents, we'll say this represents P, this represents H. And so we get this here. Okay. And so I won't go through the rest, but we can move this around. Let's just look at Z. Z is not in our message, but if we wanted to do F of 25, we will have 25 plus 3, which is 28 mod 26. Okay. What do we notice? 28 mod 26, that remainder is 2. So that tells me that the Z would map to C. So Z in our plain text with our key, our encrypted value will be C. So now that we have encrypted the message, meet you in the park, okay, so we only did the first 2. When it gets to the receiver, okay, they want to now decrypt this message. And so to decrypt this message, we're going to use this, what we call F inverse of P, which is now going to be the formula P minus 3 mod 26. So this shifts the letters back 3 units. So it goes back to the original thing. So it sounds pretty simple, but the thing is, we'll see that the codes can get a little, the shifts can get a little heavier. So of course, this is what we call decryption. So if I write down what we had for the word meet, so we had M-E-E-T, okay, and the M-E-E-T represented, I think, 12, 4, 4, 19. And so when we do the encryption, we got 15, 7, 7, and 22, which left us with the letters P, H, H, W. Okay. So now let's decrypt. We are going to just decrypt one of our letters. Okay. Let's just decrypt that M. Okay. So if I decrypt M, I'm going to now, this is what the receiver has received. So they're going to do F inverse of 15 because this is what information they have. And so they'll have 15 minus 3 mod 26. So they'll get 12 mod 26, which is just 12. And then we can look back to the top and see that represents our M. And we can do this for the full message to get what my original plain text was. Okay. So this integer K, this K in our case was 3 because this is the Caesar cipher. Okay. This K is what we're going to call our key. And that's the information that the sender and the receiver has to have to be able to decrypt a message or encrypt the message. Now, I want you guys to work on one on your own. Okay. And this is what we're going to call just the general shift cipher. So if my key is, say, 11, okay, we can choose any value. That means we shift 11. So, for instance, if we want to do stop global warning, S represents 18. So we would do F of 18, which would be 18 plus 3 mod 26. And so 18 plus 3 is 21 mod 26. Okay. Oh, I'm sorry. Please excuse me. Let's go back. We're doing 11 as our key. So sorry. Okay. So we got 11. What's 18 plus 11? 18 plus 11 is what? 29. And 29 mod 26 is 3. Right? And 3 shifts to the letter D. Okay? So A, B, C, D, 0, 1, 2, 3. And so the first letter of this is now D. What I want you to do is pause and take a second and to complete this encryption. Stop global warning with key 11. Okay. Once you've gone through this, the solutions are on your slides. But here we have, for our solutions, we get this new text here, okay, which is our encryption of stop global warming. Okay, now we want to decrypt this message. So I can't say what this message is because I can't pronounce this because it's already encrypted. Okay, but we're going to use the key of 7 for this one. So in this case, we'll do F inverse. We notice that the first letter is L, represents an 11. Okay, and so we'll do 11 minus our key. Our key was 7 mod 26. Okay, and this gives me 4 mod 26, which is equal to 4. And then we notice that 4 maps to E. I want you guys to finish this decryption and let me know what you get. Okay, we have the solution here. If you go through this message, you'll see that you'll get experience is a great teacher as your decryption. So the other ciphers we looked at were what we call shift ciphers. Now we want to look at a special case of the shift cipher, which is the Affine cipher. And it uses this form here. P of F is equal to A times P plus B. Okay, and so A and B are integers. Children, that F is a bijection. And what is a bijection? It's just that the greatest common denominator between the values of A and 26 is just 1. Okay, so let's look at this example here. We want to replace the letter K with the function P of F, which is equal to 7P plus 3 mod 26. So if you look in the above slide, so you go through, K represents the number 10. So we want to find F of 10. And F of 10, in this case, we have some integers. 7 and 3 are my A and B. So we'll do 7 times 10 plus 3, mod 26. And so that gives me 73 mod 26. When you do this, find the remainder, you get 21. And you'll see then that 21 maps to the letter V. Okay? And so you can use an Affine cipher to find different decryptions. Okay. So I should have said encryptions earlier, but I said decryptions. So to decrypt, okay, we actually have to move backwards and solve back for what that letter would have been. We will not actually, sorry about that, the screen went away. But we will actually not be decrypting any Affine ciphers, so we won't go through this here. Okay, but you can see it and you can find in your text.